Alright, let's continue our discussion on projections of solids. Now, in the last lecture, we have solved two problems, and let's solve some more problems. Now, in this particular lecture, we are going to introduce the inclination with Vp of the solid, right? So, let's take the same problem which we discussed last time. So, this is the problem of square prism. So, this is the solution. So, just to recall, in this particular problem, it was required to keep one edge of the base of the prism on HP, and the face containing that edge should be inclined at 45 degree to Vp. So, that is what we have solved so far. So, now let's add one more condition to this problem statement, and that condition is that the edge is inclined at 30 degree to Vp. That means the edge which we have kept on HP during this solution, that means QR, that particular edge is having inclination of 30 degree to Vp. So, first two steps of the problem will remain as it is, like this, and now we have to introduce the next condition. So, here first of all we have to observe that in which view the edge is visible with its true length. So, it is very clear that in the top view the edge is visible with its true length. So, now if we want to introduce inclination of this edge with Vp, we have to make this edge inclined at xy line with 30 degree value, right? Okay, so now to solve this problem we will need one more step, that is third step, and in the third step we need to draw a line of 30 degree angle with xy. So, we can draw that line. Let us say I am drawing it line over here. This is the line having this angle should be 30 degree, right? So, you can say this angle should be 30 degree. Okay, so this is a 30 degree line. Now, on this line, using the measurement compass method, I will put this length QR okay. So, that gives me the required edge QR, and now using the arc method I have to just reproduce this shape. So, when I will reproduce it, I will get the shape something like this. And I will give the notations. If this is RQ, then this must be point S and this must be point P. This is A, this should be B, this should be C, and this should be D. Alright. Now, we have to be careful about where to draw this, as no condition is given that what is the distance of this particular edge from Vp. We can draw it anywhere, but we should be careful that it should not cross this xy line, as well as it should be having a distance, acceptable distance from this view, so that we can easily draw it. Here, as I am not taking any measurements, this is a bit closer to the second step. So, there should have some distance between second step and third step when you are actually solving the problem. Now, we need to find the front view for this. So, what we did initially, we put the solid on HP like this, then we tilted it by keeping one edge on HP. Now we are tilting this edge, and that means whole solid like this, right? So that is the view which we are getting over here. So this is the inclination of this edge with VP, right? Now we need to obtain the front view, how it looks from front. So if I put it in front of you like this, so second step is like this. Now in third step, what we are doing is we are tilting this edge with some angle with VP, right? So it should be like this, something like this, right? So let's see now what front view we are getting. So for that we need to take projections from these points as well as from these points. And from these points we will get some projections, and now we have to match the projections to obtain the required points. So now let's start with this A. So this is A and this is A prime, so we'll get A prime. This is B and B prime, so this is B prime. This is C and C prime, so this will be C prime. D and D prime, so this will be D prime. Okay, now let's take the projections of PQRS. So this is P and P, so this is P prime. Okay, Q, we need to take projection from Q also, so this is the projection of Q, and here this is the projection of Q, so we'll get Q prime. Then we have R and R, so this is R prime. S and S, so this is S prime. Okay, so once we obtain the points, now we need to connect them, and here also we need to think about the hidden entities. So as per the clue, now outlines can never be hidden lines. So what we can do is we can first draw the outline. So this is an outline, this is an outline, this can never be hidden. Now which point is to be connected to which point? For that we can take reference of the earlier views. So here we can see this is in this top view we can see D and S, that means D and S are connected to make an edge. So here we can connect D prime to S prime with a straight line. Also we know from this view that P, Q, R, S are connected, so S must be connected to R, R must be connected to Q, and here we can see that B is connected to Q, so we need to connect Q prime with B prime. So these all are outlines, this can never be hidden. Okay, now next what we need to see is the second clue. In this view, as we are obtaining this front view from this top view, so we will see in this top view which is the nearest point to xy. So here we can see the nearest point to xy is point C. Okay, that means point C will be hidden in this view, and if point C is hidden, then the edges connected to point C must also be hidden. So which edges are connected to point C? So we can understand that A, B, C, D are connected, that means C is connected to B and C is connected to D, so that must be hidden. Okay, Then again referring the first step, top view, here it is C comma R. That means C is connected to R to make an edge. So we need to connect C to R, and that must also be dashed line, right? Okay, now what are the edges remaining? So we know that PQRS, that makes a square here. So P must be connected to S and P must be connected to Q. So now whether that should be hidden or not, that is what we need to find. So here we can see that if we are observing this view from front, that means from this direction, point P will be directly in front of the observer. That means point P will be directly visible. So that cannot be hidden, right? So if we try to understand by this, then when we tilt it like this and then we tilt it like this, okay, this is the view. Now we are observing this solid from this side, right? So it must be in front of you like this. Okay, so when you are observing it from this side, point P is directly in front of you, so that cannot be hidden. So the edges connected to P must be continuous thick line. So P and Q, P and S is connected, and we also know from the first step top view, P is connected to A. So P prime should be connected to A prime, and that by continuous thick line. So this is how the solid will look like from front when we introduce the inclination of the edge with VP at 30 degree. So one more time, I am just repeating it quickly that we started by making this edge inclined at 30 degree to VP. Then using arc method we have just reproduced this view here. Then we took projections from all the point and projections from this front view, and we matched the projection and we have given the notations, and then we used these two clues to decide which edges must be hidden and which must not be.